Welcome friends, in this new video I came with linear congruences. Friends, we have seen that two numbers are congruences modulo n if their difference is divisible by n. Now here we will talk about another concept. Yet there may be congruence equations if the linear equations of congruence is of the type ax congruence is to b modulo n. Here x contain, in this equation we have an x, and screen you can see that an equation of the form ax congruences to b modulo n is called as a linear congruences. If we put a specific value to x, and if this is satisfied by that specific value, we call that number is a solution of that congruences. So if x0 is a solution of ax congruences to b modulo n, then we have ax0 congruences to b modulo n, that is this number n divide ax0 minus b. So when we put this particular value in this congruence, this ax0 minus b should be divisible by n. If it is divisible by n, then this number x0 is called as a solution of this congruence. But by definition, ax0 minus b equal to n into y0 for some y0. Then we have ax0 minus ny0 equal to b. Okay, so look at this equation, ax0 minus ny0 equal to b. It senses ours to the linear Diophantine equations ax minus ny equal to b. So this is similar to a Diophantine equation ax minus ny equal to b having a particular solution x0 and y0. We know that the linear Diophantine equation has a solution if and only if the greatest common divisor, here in this case a and n equal to d. If this greatest common divisor d divides b, then this equation ax minus ny equal to b has a solution. So therefore we can say that ax congruences to b modulo n has a solution if and only if d is a divisor of b, where d equal to gcd of a comma n. This gives us a new statement. That means this congruences ax congruences to b modulo n has a solution if and only if this d is a divisor of b, where d is equal to gcd of a comma n. Now all the other remaining solution of this equation, Diophantine equation, or ax congruences to b modulo n are x equal to x0 plus n divided by d into t, y equal to y0 plus a divided by d into t. In that linear congruences we have minus sign here, but already it contain here minus sign, and therefore minus minus will be plus in this case. Hence the remaining solutions of these equations ax congruences to b modulo n are x equal to x0 plus n divided by d into t, y equal to y0 plus a divided by d into t. Now I will write explicitly the statement of this theorem. Okay, the linear congruence ax congruences to b modulo n has has a solution, if and only if D is a divisor of B, where what is D? D is GCD of A comma N. Then it has D mutually incongruent solutions. Now friend, we have shown that x0 is a solution of this linear congruences modulo n if and only if n is a divisor of ax0 minus b, or ax0 minus b equal to ny0, or ax0 minus ny0 equal to b. This is similar to linear Diophantine equation, and Diophantine linear equation has a solution if and only if D is a divisor of B, where D equal to GCD of A comma N. So this complete the half of the proof. Now we will show that there are D mutually incongruent solutions. Now let us put the values t equal to 0 to d minus 1 in this expression. Suppose where this t varies from t equal to 0, 0, d, 0 and 0 comma 1 comma 2 up to d minus 1. Then the x equal to, see the solutions are first solution x0, second solution x0 plus n divided by d, third solution x0 plus 2 n divided by d, likewise x0 plus d minus 1 into n divided by d. And we show that these all solutions are incongruent. We claim that these are incongruent solutions. If they are not incongruent, let us assume that if it is not possible that they are not congruent, means they are not incongruent, means any two of these are congruent if x0 plus n divided by d into t1 is equal to congruent to or is equal to x0 plus n divided by d into t2, where 0 less than equal to t1 less than t2 less than equal to d minus 1. We have taken these two, any two from this 2, and let us take that they are congruent modulo n. These two are congruent modulo n. Then we can cancel out this x0. Cancelling the x0, we get n divided by d into t1 congruent to n divided by d into t2 into congruent modulo n. And we know that GCD of n divided by d comma n equal to n divided by d, right? If GCD of n divided by d comma n equal to n divided by d, then we can cancel out this n divided by d, and we have t congruences to t2 modulo n divided by d. Okay, so remember that theorem, A congruences to CA congruences to C. If we have cancelled this C, then we cannot directly have cancelled this C from this congruence relation, and we have D congruences to, we have A congruences to B modulo n divided by D. So here GCD of n by d comma n equal to n congruences to T2 modulo D. That means that is D is a divisor of T1 minus T2. D is a divisor of T1 minus T2, but it is impossible. Why it is impossible? Since T1 and T2 both are less than D, and D cannot divide this T1 comma T2, and hence this is not possible that x0 plus n divided by d comma t1 congruent to x0 plus n divided by d comma d into t. Okay, that means these are incongruent solutions. So there are d incongruent solution, and we will now show that any solution to this problem is congruent to one of these. Okay, so let us prove that any solution which is congruent to this that is congruent to one of these. Suppose we have another solution x0 plus n divided by d into suppose let us take that is a yes. Okay, then we can apply this is a solution of that of ax congruences to b modulo n. Okay, then by division algorithm we can write s is equal to q into n or q into d plus r. Okay, 0 less than r less than d. Let us put this value here. What we get then? x0 plus n divided by d into s equal to x0 plus n divided by d into s, that is qd plus r, equal to x0 plus this dd will be cancelled and nq plus n divided by d into r, right? But nq is divisible by n, and hence this number, this x0 is congruent, x0 plus n by d into r is congruence to x0 plus n by d into s modulo n, right? That means we have x0 plus n divided by d into s minus x0 plus n divided by d into r equal to we have n into q. This subtraction is multiple of n, and in other words it is congruence to x0 plus n divided by d into r modulo n. But see this number n, see this number r. What is r? R is lies between 0 to d. That means value of r may be 0 comma 1 comma 2 up to d minus 1. If value of r is like this, then this is one of the solution x0 comma x0 plus n divided by d comma x0 plus 2 into n divided by t dash dash x0 plus d minus 1 into n divided by d. So this is a one of this solution. That means if this is a any other solution, then this any other solution is congruent to one of these solutions. So friend, we have shown that there are only d incongruent solution to this linear congruences ax plus ax congruences to b modulo n.